All right, today we're going to talk about synthetic division, and I like this a lot better than long division. I think it's kind of fun. I think it's easier. It takes a little bit to get used to, but what you're doing is you're technically set up the same way. So actually, we're going to do the same problem that we just did with long division, and we're going to use synthetic division. I think you'll see that this can be easier. Now, we're dividing by x minus 5, so what I want to do is I want to take this x minus 5, and I want to set it equal to 0, because I want to know what root, or what's the 0 that we think this is. So we're saying, hey, if my factor was x minus 5, then the solution is x equals a positive 5. Meaning if I add 5 to both sides, then I would get x equals positive 5. We're checking, is this actually a true statement? Can I divide by this factor, x minus 5, evenly into this polynomial? Or a better question is it true that x equals 5 is a solution in this polynomial? Well, one way you can check is by division. And so if we use synthetic division and we get a remainder of 0, then we'll know that this is a solution, that actually it does, x does indeed equal 5. Or x minus 5 is a factor, it does divide evenly. It's kind of like if I said, hey, what's 20 divided by 5? Well, it's 4. Well, what's 21 divided by 5? Well, it's 4, but it's a decimal, right? It's something that doesn't go in evenly. And so we wouldn't say that 4 is a factor of 21. All right, enough of that. So what we do is whatever x equals, we're going to put this in a backwards L here. And that kind of separates us from the rest of the problem. And then we're going to write just the coefficients, just the numbers attached to each variable. So I have a 1x to the third. I have a negative 7x squared. Notice how I don't have an x, so I need to put in a placeholder, 0, just like we did for long division. And then I have a positive 14 as my constant. So when I read this, I have a 1x squared, or 1x to the third, minus 7x squared, plus a 0x, plus 14. So we want to bring the signs with it. We're going to leave a little bit of space, and we're going to bring this down, or have a horizontal line separating this. And here's the process. You bring down your first term, so I'm just going to bring down 1. Whatever number is underneath this line is going to be multiplied by this number, by our solution that we're checking in our backwards L. So 5 times 1 is 5. And then I'm going to just combine like terms. Negative 7 and 5 combine to a negative 2. 5 times negative 2 is negative 10. And combine like terms. 0 minus 10 is negative 10. 5 times negative 10 is negative 50. And when I combine these, I get a negative 36. And so what we're saying is that after I divide this out, I'm left with a 1x squared minus 2x minus 10, and I have this remainder of a negative 36. And so we say, oh, I have this minus 36 left over after I divided by my original x minus 5. And this should be the same answer that we got before. And so what we're saying is that with synthetic division, because I did not have 0 as my last number, that means x minus 5 does not divide in evenly into this polynomial. So meaning that when x equals 5, it is not a solution. Y is not equal to 0. And we're going to use this to find solutions later. All right, moving forward, we have another example. So number 2 over here, we'll use purple. We have this polynomial, and we have an x to the third, x to the second, x to the first, and a constant. So we don't need a placeholder of 0 like we did in this other one. But we're dividing by x plus 3, meaning we think that if I set that equal to 0 and subtract it, we're checking, does x actually equal negative 3? Is that a solution? Is that a root or a 0 or an x-intercept when x is negative 3? Well, let's check. We put that value, negative 3, in our backwards L. Let's do that again. And we're going to then write the coefficients of each of these terms out in front. So I have a 1x to the third, a negative 1x squared, a negative 6, and a positive 18. And here's my division bar, or my separator. I'm going to leave a little space and then go through the process. So I'm bringing down the first term, which is a 1. Negative 3 times 1 is a negative 3. Combine these together and I get a negative 4. A negative times negative is positive, so this is a positive 12. Combine these and I get a positive 6. Negative 3 times 6 is a negative 18, so when I combine these, I get a 0. So I do have a remainder of 0, meaning it does divide in evenly, meaning x does actually equal negative 3 when y is 0. So this is a solution. And so how would we write this? Well, I started with x to the third, and if I divided technically by the factor x plus 3, then instead of having x to the third and I took 1x away from each term, this is going to be a 1x to the second minus 4x plus 6, and I have that remainder of 0. This is called a depressed equation. It's sad because it's smaller. And so what that means is that when I start with an x to the third and I divide out an x plus 3 or take out an x, then I'm going to decrease that exponent by 1, and I'm going to have an x squared left over. In the same way over here, I started with an x to the third, but when I divide it by an x minus 5, and I take that x out from each term, my end result would be an x to the second power.